This is the standard algorithm of adding fractions with unlike denominators. This bottom number is the denominator, and this top number is referred to as the numerator. So, by similar denominators, or the same denominator, I mean if you had 3/4 plus 1/4. These can be added together because they have the same bottom number. So, since they have the same bottom number, the whole piece, essentially, of the pizza is cut into 4 pieces. We can go ahead and add 3/4 and 1/4 because they are similar sizes or pieces. So we know that this is 4/4. We ate that whole pizza, right? So when they have unlike denominators, how do we work that? So I went ahead and I drew a picture. This represents 3/4. These boxes are the same size. I just cut them into different sized pieces. So this represents 3/4 of this box. Now this similar sized box, I cut it into 5 pieces, but I only shaded in 1. This is why we cannot just go ahead and add these, because you wouldn't be sure what to call it. Because this piece isn't going to take up this whole piece, because a 1/5 is slightly smaller than a 1/4. So you wouldn't be sure how to say how much of it is covered, or how much of it is eaten, or whatever the problem may be. So how do we get these fractions to where we can add them easier? Standard algorithm calls for you to make these denominators similar. And to do that, they want you to find the least common multiple of these numbers. So when I look at a 4 and a 5, my brain instantly goes to 20, because 4 times 5 is 20. So that's what I'm going to do. So I'm going to multiply this 4 times 5. And that's going to give me 20. So I'm going to go ahead and write that over here. And what you do to the bottom number, you have got to do to the top number, because it's not going to be the same fraction if you do not carry that out. So we multiplied the denominator by 5, so we now have to multiply. We multiplied the denominator by 5, and we now have to multiply the numerator by 5. So 3 times 5 is 15. So 3/4 becomes 15/20. How do we know that those are similar fractions? Well, when teaching a student how to add, you should have already taught them similar fractions. And they should know that these are similar fractions either by cross multiplying or by finding, again, 15 divided by 3 is 5, 20 divided by 4 is also 5. Also, you can draw pictures. So my picture here, let me get a distinguishable color. My picture here is in 4ths. If I could divide it into 15ths, I'm going to go ahead and try. It's probably not going to look so great, but I'll try. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16... 17, 18, 19, 20. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, look at that. Almost perfect. 16, 17, 18, 19, 20. Well, almost perfect. Not quite. Okay, so I divided this into 20ths. So now we see that 15/20 is the same as, if my drawing was to scale incorrect, is the same as 3/4. So now I'm going to do the 1/5. So now I'm going to look at this and say, okay, I used 20, so now what times 5 gives me 20? I know that 4 times 5 gives me 20, so I'm going to multiply 5 times 4 and get 20. and I'm going to multiply the 1 times 4. Just because I did it to the bottom, I have to do it to the top. 1 times 4 is 4. So that means that 1/5 is the same as 4/20. And I would go ahead and separate those out for you, but this is a mess. So usually when they teach this, they do not line it up this way. This is the way I prefer it, just because I'm different. This is the way it's usually lined up when it is taught. So then you could say 3/4 equals 15/20, and 1/5 equals 4/20. Now add them together. The reason I prefer it this way is because it's easier to see that the denominators are now the same, 15 plus 4 for the numerator. This way is a little bit more difficult to me, but to each their own. So 15 plus 4, that's 19/20. So we now know that 3/4 plus 1/5 is 19/20. So subtraction with fractions is very similar. Why does this work? Well, we just showed you. Because you're cutting it into smaller pieces and you're finding an equivalent denominator that both of these will work with. So subtraction with fractions, we're going to use the same numbers, is very similar. Now I'm wishing I hadn't messed up this picture here. I'll just do it again. Okay, so we have 3/4, and I'm going to change it to minus 1/5. So the same thing applies. We cannot subtract these because we do not know at this point how much 1/5 would be to take away from the fourths because they're separated into separate pieces. If these are pieces of a candy bar that you're sharing with your friends, this is how I like to show it to my kids. If these are pieces of a candy bar that you're sharing with your friends, this friend, if they get this piece and everyone else gets these pieces, this friend's gonna feel kind of mad because his piece is smaller than everyone else's. So we're trying to figure out how everyone can get the same amount of candy bar. So to do that, again, we have to find the least common denominator, or least common multiple, sorry. Okay, so to do that, we're going to do pretty much the same thing as we did for adding with the standard algorithm. So, we already said that the least common multiple of 4 and 5 is going to be 20. I'm going to set it up the same way I did a while ago. If you prefer it the other way, just go ahead and write it the other way. So now that I know that both of these are going to become a 20, I can say, okay, 4 times 5 gives me 20. So 3 times 5, again, gives me 15. 5 times 4 is what gives me 20. And I can go ahead and write it this way. Let me switch colors in case you're writing it the other way. Whoa, that's really light. Sorry. Three-fourths minus 1/5. So this becomes 15/20, and this becomes 1 times 4. What you do to the bottom, you have to do to the top. 1 times 4 is 4. So 1/5 becomes 4/20. So now we can look at it as a subtraction problem with just the numerators. What's 15 minus 4? So a while ago it was just an addition problem, so we said 15 plus 4, but now it's 15 minus 4. So that's all we have to do. 15 minus 4 gives us 11/20. Now, when you finish a problem, you always want to check and see if this can be simplified. Can this be simplified? No, because 11 is a prime number. A while ago, we had 19 over 20. Can that be simplified? No, it cannot. So, both of these were okay answers.